Yes, students, welcome to our video lecture. Today we are going to do the sums of obtaining original frequency distribution based on the given data. Now students, I am starting with the ninth sum, exercise 2.1. Exercise 2.1, sum number 9. Now students, the question is information regarding number of accidents in a city during the year is as under. Find the inclusive continuous frequency distribution from it. Students, we are given instruction to obtain inclusive continuous frequency distribution. First of all, I note down the given information. The given data is as below. Now, mid value is xi and corresponding frequencies fi 11.5, 21.5, 31.5, 41.5 and 51.5. Then 160, 120, 43, 42. Total frequency is n is equal to 365. Okay, now students, based on this, now students pay attention here. The difference between two consecutive bit values will be class length. All of you students pay attention. The difference between two consecutive bit values, check pairwise, I am showing the arrows. 11.5 and 21.5, the gap is 10. 21.5 and 31.5, the gap is 10. 31.5 and 41.5, again the gap is 10. So, the second aspect, when gap between two consecutive mid values remains constant throughout, that constant gap, students, becomes the class length. Now, so we write here the gap or difference between consecutive mid values is 10. Therefore, class length C is 10. Because class length was not given. And without class length, students, we cannot use those formulas to find lower limit and upper limit of a class. So lower limit is equal to mid value minus half the class length, and upper limit is equal to mid value plus half the class length. Now I am showing for first class. Lower limit is equal to mid value minus half the class length. What is mid value? 11.5 minus 10 by 2. So it is 11.5 minus 5, so it is 6.5. Then, students, for upper limit, it is mid value plus half the class length. 11.5 plus 5, so it is 16.5. Then for second class, we will have lower limit is equal to mid value minus half the class length. 21.5 minus 5, so how much? 16.5. And upper limit will be mid value plus half the class length. So 21.5 plus 5, and that is 26.5. For third class, we will have lower limit is equal to mid value minus half the class length. What is mid value? 21.5 minus 5. So it is, it is 31.5 minus 5. So it is 26.5. And upper limit will be mid value plus half the class length. So 31.5 plus 5. So it will be 36.5. Okay, students, so for fourth class and fifth class, I am not showing the calculation, it will be 36.5 to 46.5, and for the fifth class, it will be 46.5 to 56.5. This is how, students, we will get all the class limits. Pay attention, the most important part of the sum, class length was not given, and class length can be considered as the gap or difference between consecutive bit values which is same throughout. So here, students, the class length is 10. Now the most important point, that these classes are not inclusive, but these classes are exclusive. Check 6.5 to 16.5, then 16.5 to 26.5, 26.5 to 36.5, 36.5 to 46.5, and the last class 46.5 to 56.5. Okay, no problem. First of all, rewrite. First of all, students, we will write. So, the exclusive classes. And then we will convert this to inclusive classes. The first exclusive class was 6.5 to 16.5, 16.5 to 26.5, 26.5 to 36.5, 36.5 to 46.5, and 46.5 to 56.5. All these are exclusive classes. But if I read the instruction of the question, it is given, find the inclusive continuous frequency distribution. Now, while converting exclusive to inclusive, remember, we add 0.5 to the lower limit and subtract 0.5 from the upper limit. Reverse of finding boundary. Well, finding boundary points, we subtract 0.5 from lower limit and add 0.5 to upper limit. Here the reverse process we are doing. Subtracting means here, once again, for boundary points we used to subtract 0.5 from lower limit and add 0.5 to upper limit. Do opposite. Add 0.5. So 7. and subtract 0.5. So 60. So the first class is 7 to 60. Again, add 0.5. Add 0.5. So 17. Subtract 0.5. So 26. Add 0.5. So 27. Subtract 0.5. 36. Add 0.5. 37. Subtract 0.5. 46. Add 0.5. 47. Subtract 0.5. 56. So remember, while converting exclusive classes to inclusive classes, add 0.5 to lower limit and subtract 0.5 from upper limit. This much we have to remember. It is opposite of boundary points. While converting exclusive to inclusive, add 0.5 to lower limit and subtract 0.5 from upper limit. Students, this is something different. So remember, like this, while converting exclusive class to inclusive class, add 0.5 to lower limit and subtract 0.5 from upper limit. This will go down as a formula. So this completes, students, our answer number 9. This completes, students, our answer number 9. Now still two sums of exercise 2.1 are pending that we will do afterwards, and those questions are questions 6 and 7. Now we will do similar sums from exercise 2 section C. We have already done, students, sum number 7 and sum number 8. Today we are doing section C, sum number 9. Now all of you please pay attention. Exercise 2 section C, I told you we will be doing similar type of sums together. This is my method of teaching which will remain universal. So don't worry, we will complete similar type of sums, students, at a stretch. So now, students, we are doing exercise 2 section C, sum number 9. Exercise 2 section C, answer 9. Now it is told that prepare less than type cumulative frequency distribution from the following distribution. Okay, so we start with the given discrete frequency distribution is as below. We note down xi and corresponding fi. 10, 20, 30, 40, 50. Frequencies are 10, 30, 30, 20, 10. If I total, then 40 plus 30, 70 and 30, 100. So total of Fi, students, is 100. Okay, now students pay attention. So we have started the 9th sum of section C, students. We are doing the 9th sum of section C. Here it is told to prepare less than type cumulative frequency distribution. So I give the title less than type cumulative frequency distribution. Mind you, this is a discrete distribution. So in the first column we write value of xi value less than or equal to xi, means the value Here xi is not given in terms of any description, so we write less than or equal to xi. And second column, corresponding cumulative frequencies. Now we note down all the x's which are starting from 10, 20, 30, 40 and 50. Now cumulative frequency for 10 is 10, for 20 it is 10 plus 30, 40, then for 30 it is 10 plus 30, 40 plus 30, 70 plus 29, 100. I told you we end at maximum, which is the total. Clear, students? All of you understood? If I wanted to prepare more than 10, then I would have started with 100, 100 minus 10, 90, 90 minus 30, 60, 60 minus 30, 30, 60 minus 30, 30, 30 minus 20, 10. So that is how we obtain the more than type cumulative frequency distribution. But that I am not finding. Here it is only told students to find less than type cumulative frequency distribution. Okay students, now section D, we are doing sum number 8. Obtain the original frequency distribution from the following data. So it is very similar to the 9th sum, but here no instruction is given. So whatever exclusive class limits we will obtain, that we have to keep as it is. 8th sum of section D. Obtain the original frequency distribution from the following data. So today we will complete, students, all the sums of obtaining original frequency distribution. So first of all, I note down the given data. Section D, exercise 2, sum number 8. So we write the given data is as below. We note down mid values xi corresponding frequencies f1, 250, 350, 450, 550, 650 and 750. Corresponding frequencies are 20, 80, 80, 40, 60 and 20. Total frequency is given as 300. Now once again students, whenever it is the sum to obtain original frequency distribution, we need to find class limits. To find class limits, I have to use the formula of lower limit and upper limit. And for that we require class length. Class length is not given, but we check the gap between two consecutive mid values remains the same, which is 100. So we start with the gap or difference between consecutive values is 100. Therefore, class length is 100. Now, first class limits. All of you know, lower limit is equal to mid value minus half the class length. 250 minus 100 divided by 2, so 50, so directly 200, and upper limit is equal to mid value plus half the class length. Half the class length is 50, 250 plus 50 is 300. So first class is from 200 to 300. I'm writing here classes. So the first class will be from 200 to 300. Then students, second class, lower limit is equal to mid value minus half the class length 350 minus 50, so 300, and upper limit is equal to mid value plus half the class length, so 350 plus 50, and that is 400. Then for class number 3, we will get lower limit is equal to mid value minus half the class length, so 450 minus 50, so 400, and upper limit is equal to mid value plus half the class length, so this becomes 450 plus 50 students, so 500. Now I can observe that the classes will be 300 to 400, 400 to 500, 500 to 600, 600 to 700, and 700 to 800 students. I am leaving for you to do for 4th, 5th. How many classes are there? 3, 4, 5, 6. So the remaining 3 classes, 4th, 5th, and 6th, I suppose you can easily do on your own. 550 minus 50 will give us 500, 550 plus 50 will give us 600, 650 minus 50 is 600, 650 plus 50 is 700, 700 to 800. You can easily do students on your own. Okay, now students, we are doing sum number 12, which is also of the same type. Check from the given data below, obtain original frequency distribution. So students, this formulas are keeping as it is. I am not erasing this formulas, as this formulas means the same. Class length, let us check what it is. And this data will definitely change. Section D, students, sum number 12. The given data is as below. Mid value xi. Mid value start from 12.5. Okay. 12.5, 17.5, 22.5, 27.5, 32.5, and 37.5, 42.5, and 47.5. The corresponding frequencies 12, 18, 16, 22, then 14, 10, 6, 2, 14, 10, 6, and 2. If I write the total frequency is not given. Okay, students, here as such we don't need total also, no need to write the total. Check the gap between two mid values is 5. Check pairs. Here also 5, here also 5, here also 5, here also 5, everywhere 5. So the class length is 5. Now, students, here also I am obtaining for say 5 classes, remaining you can easily do on your own. Lower limit of first class mid value minus half the class length. 5 divided by 2, 2.5. 12.5 minus 2.5 is 10. Here, 12.5 plus 2.5, so 15. Second class, 17.5 minus 2.5 is 15. And here, 17.5 plus 2.5 is 20. Same way for class number 3. 22.5 minus 2.5 is 20. And 22.5 plus 2.5 is 25. Okay, for the fourth and fifth class I am showing, then you can easily write, but you have to calculate mid value minus half the class length. 27.5 minus 2.5 is 25. Upper limit mid value plus half the class length. 27.5 plus 2.5 is 30. Okay, for the fifth class I am showing the lower limit is equal to mid value minus half the class length. So 32.5 minus 2.5, so 30. And upper limit is equal to mid value plus half the class length. 32.5 plus 2.5, so 35. Similarly for 6, 7 and 8, check how many values? 4, 5, 1, 2, 3, 4, 5, 6, 7 and 8. So 8 classes are given. So the first class is 10 to 15, second class 15 to 20, class number 3 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50, 3, 4, 5, 6, 7 and 8. 8 classes students we have already did. So students, this type of sums are very interesting sums. Why? The first important thing, class length is not given. When class length is not given, universally all the classes will have same class length. Difference between two mid value becomes the class length. That is one of the most important aspect of this type of sums. So students, today we have done the sums involving the formulas of lower limit and upper limit. So students, be very careful that you understand these sums and these formulas very perfectly. This is very easy. Again, don't repeatedly ask me. You have to do these sums twice, once in farewell and once in homework. Students, remaining sums of cumulative frequency distribution we will continue, students, in the next lecture. Thank you, students.